So Gail, you're an experienced engineer. You've used a number of different survey software packages, from LSS to N4CE, AutoCAD Civil 3D, Trimble Business Centre, Topcon Magnet, etc., etc. So could you explain what survey software is and why we use it on construction sites? And what are the main features within the survey software that you found particularly useful as a site engineer? And perhaps you could explain some of the common, abbreviations and terms we might come across, like CAD or DTM.
So to answer your question, Saffron, I think coming from a site engineering background, and as you say, the range of softwares that I've had the experience in using, I think some of the main benefits for me anyway was the ability to, I suppose, more accurately produce measurements on the site. So when I talk about that, I mean things like areas and volumes. Just to give you an example, let's say, we were putting in a 10 by 10 area of concrete with 300 mil deep. You could obviously quite quickly work that out using a calculator. 10 by 10, you would get 100 metre square. Multiply that by 0.3, you would get 30 cubic concrete. But that assumes that the base of where the concrete is going to be sitting on is constant. So where engineering software can come in is that you could go and survey that area, put it onto a form of engineering software so that it will accurately or more accurately determine the volume of concrete. So it stops you from over or under ordering the concrete. So, and as you know, concrete is quite expensive. Stockpiles as well, just on the topic of volume. So if you've got a stockpile on site, you've dug out an area that maybe a building's going to be going into, the stockpile's then sitting somewhere on the site, and at come the end of the project, you need to get rid of that stockpile. So in order to be able to find a home for it and a suitable area for it, you need to know how much material's in the stockpile to be able to find a home for it. So whether it means that some of it needs to go off site, some of it stays on site. So again, you could survey that stockpile, plug it into an engineering software, and within a couple of clicks of a button, you can find out an accurate volume. So that has always been a really useful one for me. Some people might be familiar with the term takeoffs as well. So it's basically a fancy word of saying, how do you calculate the amount of material that you need on site? So again, that's a great one of drainage. So the designer will give you a drainage model, but how do you work out how much pipe do you need? How many manholes do you need? So you could quickly put that into an engineering software. And again, very, very easily, you can create a report in some cases that will tell you how many metres of, 300 mil pipe you need to buy for that entire project. And on the subject of drainage as well, when it comes to water management, and it's completely invaluable, is that especially in Britain, as you all know, we've got the wonders of the British weather to contend with on a construction site. So before you set foot on the site, you've got the best of intentions to manage water runoff on it. But when you're actually on there, you find that there's different areas of the site that will just be flooded that wasn't picked up in the original site walkover or the original site survey. So once you're physically on site, you're able to do a survey of the area, put it into engineering software, and you can physically see it. You don't need to work anything out. You can see it, the way that the water will flow, and where is all that water going to be getting collected. So you're able to do that within the software, quickly analyse so that you can put in mitigation measures such as silt nets or swales, temporary measures that's going to stop you having a problem on the construction phase of your project. The difference really between CAD and DTM, and these are terminologies that I've just found over the years, it's confusing the industry. When you hear a lot of people saying, oh, I'm using CAD and CAD this and CAD that and CAD this, and a lot of the time people expect that to be AutoCAD when they say the word CAD, but in actual fact it's not. AutoCAD do not own CAD. It's not, CAD isn't a physical thing. CAD is a terminology. It stands for computer-aided design. So it's maybe a bit of good marketing in some senses, but Where DTM slightly differs from that, so DTM stands for digital terrain modelling. So that is where you can produce this thing called a 3D mesh, a triangulation model, some people will call it, and it's basically a fancy way of saying a 3D surface for the site. So that is the difference between CAD and DTM. So if you had a company that was called, I don't know, something DTM, it doesn't mean that they own DTM. It's just they've incorporated that name into their name, which is similar to what AutoCAD has done.
So Nigel Loriman, the General Manager at McCarthy Taylor, and they provide LSS DTM software. So can you tell us a bit about the benefits to businesses, large and small, about the benefits?
Okay, thanks, Saffron, and thanks, Gail. It was very, very interesting, very clear summary. It helps pave the way for the rest of us, I guess. My personal area of interest, company bosses value every bit of earth-moving kit because they know how much it costs and they know how much it's used on site. Plant and machinery can be touched, but software can't. So, how does the engineer decide how much muck to move and where he's going to move it and what have you? And the software they use for that is massively underappreciated at the moment. I mean, BIM was supposed to change all of this, and eventually I guess it will. I think there have always been disputes on site, especially over volumes. And it used to be the practice, I think, that people in dispute used to split the difference. I often heard that for years and years and years. Oh, let's split the difference. And it's always been our contention that our users should never compromise or meet halfway. If they're happy with their data collection, their accuracy, their methodology, then why meet halfway when you can prove what you've done is accurate? More recently, the move towards pegless excavation and machine control, in our view, has been a great thing for engineers. I think many feared that automation would do them out of a job, but peg bashing was never the most glamorous job, as I'm sure you will testify. Now, armed with the right software, an engineer can import a design, check its integrity, and make any amendments he or she feels are necessary, and then upload it to a cloud server and then onto the excavator for creation of the site. The engineer then is free to manage a project and quality check a design, which quality checking a design is probably more common now than you could possibly imagine. They can't do this if they're up to their knees in mud on site. So believe it or not, quite a high proportion of our time on support is spent sorting out problems with customers' data, or helping them with survey methodology, doing training, etc., when their survey doesn't process. So even once an organisation has bought into the concept of digitalisation, I think it's the quality and depth of knowledge that customers should be looking for. And that level of support and expertise is only available, in my view, from dedicated companies such as ourselves and applications in CAD. Well, I think the resistance is never from the person who would end up using it, which is significant. It's usually the ones, they're the ones contacting us in the first place, and they're the ones that are struggling to convince their bosses of the benefits. Thankfully, there are fewer companies out there that refuse to entertain the use of software. What we're fighting against these days is the misconception that CAD software can do everything. It's the universal panacea. Admittedly, you can probably manage to cut I don't know, you're chopping up a plank of wood, you could use a lump hammer for that, but it's never going to give you the right result, is it? But then again, even with the right tool, if you're not trained in its use, you can still create all sorts of havoc. So it's not just, in my mind, the software that counts, it's the whole life support that's lacking from the way too many software vendors out there and is putting off some customers. They get a bad reaction from someone, they buy a generic bit of CAD software, they don't get the level of support they need to sort out problems, and it puts them off. I think the most forward-thinking organisations, I can quote some big names here, like Balfour BT, Jacobs, Royal BAM Group. They involve directors, project managers, engineers, IT, HR, and the decision-making process is done by all of those. More often the spark is the engineer on site, but it spreads throughout the organisation, and then everyone comes on board, and then IT then starts to invest in the solution, and that helps everyone.
I'll move on to Phil. So Phil Langrish, co-founder of Applications in CAD, who supply N4 software. So, N4 is capable of importing and exporting to a wide range of file formats so that files can be altered to suit other people's software platforms. So why did N4CE decide to do this as opposed to only working with N4CE only files?
When it comes to file formats, at the end of the day, it's good to talk. Interoperability makes the world go round. All the manufacturers, I'm talking the hardware manufacturers, have their own file formats. Obviously, you have to be able to create XML files, you have to be able to create DWG files or PDFs, because it's going to end up in another package someday. And so, you have to be interoperable. And
yeah, it does sound like that. The interoperability is coming much more to the forefront now as an expectation rather than a luxury. So why do you think that site engineers often use AutoCAD as well as other softwares such as N4CE or LSS when they have some or all of the CAD capabilities? Preconceptions.
DWG, DXF originally came from Autodesk. And if you double click a DWG or DXF, it will probably open up in your CAD package. If you double click a PDF, it will open up in Adobe Viewer or whatever you have, to view that in. Our software can import the DWGs and the DXFs and extract the setting out information. It can import the PDFs and reverse engineer that to get the setting out information. Even if there's a, coordinate system's being screwed up, we can still work with that. I guess there's just a legacy that CAD has to go into AutoCAD, but our software is as I said before, like a Swiss Army knife with 1,000 tools. We're much better at processing and handling site-specific CAD drawings, layouts, housing estates, earthworks diagrams, drainage, you name it, alignments, road alignments, in our own way, because that's what the software is specifically designed to do. Otherwise, you end up with a CAD package with a plethora of plugins all the way around the outside, and there's no cohesion between those plugins. Our applications are designed to work from the ground up to give a field to finish solution.
But Gail and I, and Chris, through the work that we're doing with digital construction skills, we hear all the time from engineers that they're desperate to get their hands on this type of software because they know it'll make the job quicker and easier. But their employers just won't let them have it, because they don't understand the value that it can add. But what do you think the message is we need to get to leaders, training managers, decision makers, about the role that survey software or survey mapping and modelling software, which I'm going to call it from now on, the role that plays in improving profitability. How can we help engineers to make that business case?
If I were to name a CAD package, it would probably be AutoCAD or Civil 3D. That's generally where most people perceive, everyone should be working. But for the same reason that you don't play around a golf with a spoon, you shouldn't be using that to do these particular tasks. I've heard so to answer your question, how do you get the point across? If people don't want to change, then they won't. People don't like change. But what generally makes people think twice is when they see something done faster to a higher standard and with a lot less effort. And that generally, you have to basically take that horse to the trough and make him drink. And the only way of doing that is to sit on a demo, a bit like we're doing here, but you'd have all the staff, all the members, all the decision makers, the people with the purse strings, show them, like, here's how you're currently doing it, and this is it's taking X long to do it, and then this is how we could do it. And the number of times that I've had people like laughing, joking, swearing, just walking out the room because they've realized they've just spent 2 days doing something we can do in literally 2 seconds. Sometimes it's that dramatic, especially people who draw sections manually, Jesus. So
we need to be getting pointing them in the direction of just get a demo, and that will,
Yeah, you haven't lost anything. If someone can demo it for free, which we'll all do, then you can make your own decision. But if we're driving it, then you're going to see the best that software can do.
Yeah. And if you haven't got half an hour or an hour for a demo, then you probably shouldn't be making these decisions about that are going to impact on a company. So we'll move on to Adam Ball now. So Adam Ball, you work for Leica. Would you give us an overview of BIM and explain, where the currently available softwares will fit into BIM?
Data from survey softwares. It's more about where it fits into the BIM process, I think. So initially, survey data, of course, provides initial spatial information. So, for example, a survey, whether it's a topographic survey, measured building survey, utility survey, the survey information drops in there. So that initial data is what the designer would be able to then use to make sure his design actually fits into the space and the environment that's actually there in the real world. So he can't design without that real world information to make sure that his design works. So that's the first place really that we see survey information being used in the BIM process. Secondly, it gets used within the construction of the building. So this is the setting out phase. So essentially the survey information can be passed back through the survey software, for example, to be able to provide information for the site engineer to be able to then lay out accurately and position that design on the ground, so it sits in the correct place within specification. So there's two places for survey information. And the third place, and generally viewed as the final place, is actually recording the constructed position of the building and the elements within the building. So this is generally referred to as the as-built phase, or could just be the verification phase, or verifying that the actual physical construction has been constructed as per the design to within the specified tolerances. So that is where I would say survey software and survey information within the BIM process.
So Peter Roberts, you work for Topcon. So survey softwares, like all things digital, are constantly evolving, being updated to include more useful tools for the end user in one package. You know, for example, in last week's webinar or podcast that we did, the panelists discussed machine control, and it was mentioned that machine control and as-built surveys can be sent straight from the cab to the office through the cloud. Why are all businesses not working in this way on the cloud? And what barriers have you encountered from businesses about these digital ways of working?
So have we got a take-up of this? What are the barriers? You know, how can we actually, what we're seeing in industry? Well, we're finding out that a lot of people don't know we can do this. That's it. Ignorance is a big thing, and that's where DCS comes in, you know, education of clients, etc. Also, under the sort of the idea of change, you know, nobody likes change. Like traditional working practice and site engineers who are fearful of that sort of change because they think it's taking their occupations away. But the way to combat that is to say, well, look, guys, we want you to be more data managers. We want you to be able to handle data. You know exactly what that machine driver wants to see. He doesn't want a lot of the superfluous information that's provided on CAD models. He just probably wants a left-hand channel, right-hand channel, and a surface to dig to. And so that they can dilute that information to exactly what the driver wants. Then they can actually also reinterpret the data that's coming back from the machine as a 3D model and a weekly measure and a progress, etc. There's a bit of a myth that machine control and cloud solutions are just for big jobs. And that's a fallacy. You know, they see these big motorway jobs, etc., big projects. But even this, if you can imagine a site engineer having several sites to work on, running around like a bit of a headless chicken, bit of setting out here, bit of setting out there, he effectively could manage all those sites from his desk pretty much by sending out the right models, sanity checking the models, sending them out to the machines. And it's education of the drivers as well, of course, so that they understand what they're receiving. So really, one of the questions is, why should I invest in machine control? And it's because as sort of plant operators become more automated, it's the decisions that we make on sites are highly influenced by this data that's coming in. And I think we just need to, I suppose, engage industry in the fact that all these, the benefits of sustainability, environmentally friendly, and leaner working, more productive working can be sort of gained through these cloud solutions.